Okay, thank you. I suppose maybe to start with a little bit of background to, I suppose, what this presentation is about. In Mayo, like probably a lot of other local authorities, construction has been predominantly traditional build, block work, and that's what we've been used to. Over the last couple of years, there's been a slow infiltration of MMCs. Last year, we noticed a significant increase in that. So we started to look at how they demonstrate or outline how compliance with building regulations is met. We're still thinking about it, still looking at it, but I was asked to come here today maybe to go through some of our thoughts on it. So at commencement stage. Is this going automatically? No? I'm not sure where we... right, sorry. We all know what the basic requirements are for commencement notices. They have to be filed electronically, preliminary inspection plans, certs, notices, fees, and so on. But they have to be accompanied by such plans and calculations, specifications and particulars necessary to outline how the building regulations will be complied with. And that includes general arrangement drawings, plans, sections, schedule of plans, and so on. What we don't want is the planning drawings coming in. And I suppose I'm starting this talk with the basics. Some of the requirements for commencement notices or the submissions, it's the same whether it's a traditional build or whether it's an MMC. You know, looking at getting this keeps going forward on me. Getting a planning drawing just isn't going to cut it. There's no information there. What we want to avoid is the likes of this when it goes out on site, and without proper detailing and structure, that can occur. We can get that. We're looking for construction drawings. We want details. We want proper specifications. We want to see foundations, foundation detailing. I don't know if you can see that, but we'll say the stone there, it's properly specified. It's to SR21. They've detailed in the a T3 around the radon and so on. So it's properly specified. At least when it goes out on site, it then has a chance. This is another example. Again, properly specified hardcore fill T3, T2, T1, all to SR21. Overall, what we want to see is there sufficient detail provided to show building regulation compliance. We want to see the details of foundations, radon membranes, hardcore, the walls, wall ties, lintels, windows, and so on. Down Part L specification report, that gives us an awful lot of information. Right, what modern methods of construction? Once we get through the basics, we start looking at some of this. What is it? It's an innovative term used to describe a range of manufacturing and innovative alternatives to the traditional construction process. There's a number of types: volumetric, panelized, sub-assemblies, pods, site-based, and this keeps going. Sorry, my apologies. The slide keeps going forward automatically. The main parts that we're looking at with MMC are parts A to D and Part L. Part L is always going to be important. We can sometimes get Part E in. A lot of the others might become just part and parcel of an overall system. Okay, how to show building regulations requirements. The guide to agreement certification produced by the NSAI is a good start for them. It aims to enhance the certification process for MMCs and provide a clear pathway for the system manufacturers to get agreement certification. And this will be talked about later on in the day. The process applies to those products and processes which don't fall under the scope of the typical or standard construction details and procedures that we're used to. The NSAI assess for compliance with the regulations and where appropriate issue a cert. And this confirms that the product is fit for use and complies with building regulations. I think it's important for, if there is an agreement cert with the product, it's important for us all to become familiar with it and know what it includes and what it excludes. Some of the products, like a volumized system, may well cover all of the regulations, whereas a panelized system, a wall, is only going to cover certain parts. So we need to know when we're looking at a commencement notice what it's covering, and we can default back to the other processes then for checking compliance if it's not incorporated in the agreement cert. The cert itself covers aspects such as the specified use, the assessment, technical specifications, various design data, and investigations or tests. So, for example, under specified use, it'll highlight what the product or the system is has been tested for and certified for use for. This is an example, just looking at an ICF system, specified use. There's 2 uses for this particular example, a 6-story or 5-story, or up to a maximum of, but you can see that the purpose groups, they're 1C, 2A, 2B, and so on. So it's very specific. So when you're looking at a commencement notice, it's important to check and see what does the agreement cert tell us it can be used for, so that the product is being used in the correct manner. Most, if not all, of the agreement certs that I've looked at tell us that, as for the installation aspect of it, that the construction on site must be done by approved or trained installers in accordance with the installation manual. If we all know the problems that can occur, particularly with opt-outs, and then if you've got the owner has decided he's also the designer and the builder, has he been trained? Is he approved to install the likes of an ICF system or any other system? I'm using ICF here as an example. We should be looking for the clarification as to, or the certification of his approval and his training by the installer. And I have seen, when I've gone out on site, I've seen an ICF system going up, and it's the guy next door who wasn't very busy, and he said he'd throw it up. Sure, it's only a bit like Lego block, you know, and you can see where that one was going. So we need to check and see. If the agreement cert says it must be done by an approved installer, then it should be, and we should be seeking that clarification. Okay, just another example on using ICF again. The agreement cert will typically have a breakdown of, keeps doing this. It typically has a breakdown. So here's a breakdown of an external wall. You've got the external render working inwards to the internal plaster. These are pictures of an ICF building. You can see the ICF blocks externally. It's been battened. There's membrane been put over it, and the concept there was that it was going to be clad. And just try and stop this. But anyway, now we did check the commencement notice afterwards. This is not a commencement notice issue, but it's maybe that it points to the fact that we should be checking it at commencement notice stage. In this particular case, the commencement notice did show up a render system, but there was a design change during construction, and they went for a cladding system. And when we looked on site, we found it was directly by this. The point is, it wasn't in accordance with the agreement cert, and the agreement cert specifically said that it needed an external render. The result being that they had to take everything down, strip it back down. They plastered. They still wanted the cladding on the outside, so they plastered it. It now complied with the agreement cert, and now they put up an external cladding system for the visual appearance that they wanted. So we need to check when we're looking at the commencement notices. We should be checking to see that are the details provided within the commencement notice or on the drawings, are they the same as provided for within the agreement cert, what has been certified for use. Okay, so now what if there is no agreement cert and we're still have to try and validate this commencement notice? Again, we're looking at such plans, calculations and specifications necessary to outline the requirements. Is there a technical specification or is there a system manual? Here we're going to use the example of a steel frame building. And how do we go about identifying that it complies? The main elements being Part A through to Part D and Part L. Has it been structurally designed where we know what our block work does and our lentils and so on, what our maximum wall length sizes are? But where we're with a traditional build, but when we're looking at a steel frame, is it structurally designed? So it should be, and it should be to the EN codes. So what do we do? Do we request calculations or do we look for a certification from a competent person and look at also then for the construction details so that when we're out on site, we know what we're looking for? If you have the time and resources, you can look for the calculations. Have you the competency to go through that, the structural design calculations and see that it is, or do you look for a cert? Personally, I won't do that. I'll probably try and look for a certificate from a competent person, an ancillary cert saying that it has been structurally designed. It's allowed for in the code of practice. Here's just a breakdown of an ancillary cert, and it confirms that I've been commissioned to carry out structural calculations on this by the client. I confirm that it has been structurally designed and it complies with building regulations. If I get that, that's probably going to satisfy me rather than looking at copious pages of calculations. I'd prefer see this and then get out on site to see that it's actually been done correctly. Okay, move on then to Part B. So Part B needs structural fire resistance, and it also needs behaviour in relation to fire. And we also want to consider penetrations for downlighters, extract fans, and detectors. So the fire tests are required, and they should be carried out by accredited EU test laboratories. What we want there is quite simply a copy of the fire test report showing that it complies with the requirements that are contained within our technical guidance documents. So we want to see that report. We also want to know what happens with, so we want to load the makeup of the walls, and we want to see what the what sort of fire stopping is both required and is provided. You can see the image on the right-hand side there. You've got a putty pad. You've got a PVC socket unit. Should that be a PVC socket unit or should that be a metal unit? What way is it fixed internally within the structure? These are all sort of things that we want to be thinking about and considering. Part C, exposure conditions for Ireland. We get a lot of, we've had a number of queries from companies in the UK. It was mentioned earlier, and coming in with BBA certs, but are they suitable to Irish climate conditions? And even you can see the variance there on the right-hand image of the wind-driven rainfall records for Ireland. I live in one of those little dark blue patches. a lot of you here maybe come from that yellow patch where you might be able to hold the umbrella up vertically, but when on a windy day, might have to hold it horizontally. That's also hitting the wall. So is the building walls, is it going to be able to take that rainfall, that penetration? You also have to look at it from a structural point of view. Has to be structurally designed for those conditions. We want to look at radon, the moisture from the ground coming up with steel frames. Some of them are on a standard type foundation, some of them are on pads. So we may be into the traditional form of foundations and protection of moisture from the ground, of protection from radon, or they may be up on pads. Also want to look at drainage from the cavity. Again, take these windy conditions, take the exposure conditions that we have to contend with, and is there a cavity there, or is there an alternative means, and how can they demonstrate that it has been that it has been designed to cater for those conditions. The cladding system as well, some of them have block and plaster or render on the outside, external. Others have claddings. Are those cladding? You have to look at the difference between the cladding below DPC level and above DPC level. So, are they proper materials? Have they got the required durability and so on? Will they do the job? Part D. Basically, a bit like Simon mentioned earlier, we're looking at, we should be looking for CE and DOP of the various products, steel frame through to the cladding systems. What are these products made of? If there isn't an agreement cert, we don't know that they're all okay. So while there's a body of work in it, it's probably important to attain those CE and DOPs. The durability, the main structural and key elements of buildings should satisfy or should last for a minimum of 60 years. There's other non-structural or individual components, NSAI, agreement cert, I think their documentation shows they're looking for 25 years on that. Other aspects that we need to consider is the delivery to site. And I don't know, does this necessarily fall in under commencement notices or not, but it's maybe pertinent to Part D, materials and workmanship, storage, the movement of the products on and off site. Are they exposed to elements that they shouldn't be exposed to, or are they properly protected? And what is the factory production control process and method of demonstrating compliance? What sort of proofs are there? These units come out on site. They're pre-manufactured and assembled on site, and we're not able to see what's behind the facade. So I think we need to be finding out what their process is, their method of demonstrating compliance. They should have one, and to me it falls in under Part D, and it's a relevant question to ask. And finally, we also want our Part L specification. You're probably all familiar with that page. We need that at commencement notice stage. A building should be designed to comply. If we want to let it ride on this one, we want to avoid images like this. We don't want black spot. We don't want thermal bridging. So have the buildings been designed to the ACDs? Is there thermal modelling of the junctions carried out, and condensation risk analysis and so on? And that the assessments are carried out to the relevant standard. And I think that is it is. There's a lot of different bits there that we're looking for, a lot of different things that we need to try to ascertain compliance. at commencement notice stage. It's getting too late when it goes out on site. It's not. It still has to get fixed. But if we can nail these things down at the beginning, if proper drawings and detailing and specification has been carried out before they commence works on site, then there's some chance that it's going to be done correctly on site. Okay, that's where we are. That's what we've been looking at. Thank you.